With all the work that needs to be done on the mitigation side and the adaptation side, in addition to infrastructure deficits and the infrastructures that society depends on worldwide, there's a tremendous amount of work that needs to be done.
And what in particular do you look at the moment in terms of what needs to be done? There's a lot of talk at this conference about adaptation, about resilience, about developing low carbon infrastructure. How would you assess how we're progressing towards those various criteria at the moment?
Well, that's a pretty broad question. You've got three different topics there. I'm going to talk about the adaptation one first. The world and the world societies have got infrastructure in place, and this infrastructure will be here for the next 50, 90 years. Some of it's going to go through renovations, and there will be new infrastructures. It was designed and built using criteria that came out of a pretty benign period of the Earth's history. That criteria is now suspect, and we need to look at our critical infrastructures, identify where the vulnerabilities are, the weakest links, and focus our adaptation monies into that area. So it's fixing the weakest link. It's not necessarily replacing all the infrastructure, but identifying where the weaknesses are.
What from your perspective, what are the hallmarks of resilient infrastructure? What particular bits do we have to look at? Because you've talked about the weakest links, but I imagine when engineers are sort of designing different, bit like the stadium, which is fantastic, it looks fantastic anyway. What are engineers looking at in terms of working out how to develop really resilient buildings?
Just looking at your example of this stadium, would you define it as a critical infrastructure? The answer is probably not. It doesn't have to be here for medical reasons or transport reasons, water supply reasons. But if you think about Katrina and how they housed a lot of people in the football stadium in New Orleans, it became a staging place for people's protection. And so you may want to look at large venues like this as critical infrastructure and then design into them the criteria related to strong winds, for instance. Yeah.
There seems to be a lot of thinking, particularly at city level, about how to integrate different parts of infrastructure, but give us a sense about your view on that. Is there enough being done in terms of drawing everything together so it works? I've heard someone describing it as an ecosystem, but is there enough from that point of view in terms of integrating everything?
All the infrastructures are integrated, and it's important for each community to understand how they're integrated and what needs to be kept whole in terms of the impact of a catastrophic event. If you look at most cities, they're on river valleys. Warsaw is a good example of that. What's the 100% floodplain or 100-year floodplain or 1% chance this year that there's going to be a 100-year event? Is it in the floodplain? What's in the floodplain? What do you need to do to make sure that the critical pieces of infrastructure, the bridge that can take you to a hospital, are taken care of? And you have to look at the criteria that were used in designing that bridge, the freeboard design, the scour, those types of things. The engineers are there, going to work every day, as I mentioned earlier. This is their job. They can look at that, they can identify the vulnerabilities, and then you can focus your money into doing that. And that's just as applicable in the developed world as it is in the developing world. We've just completed some work in Honduras, third most vulnerable country to climate change. And working with the local engineering group and using a tool that was developed as part of the adaptation, the Nairobi work program, adaptation commitment that WFEO made, we were able to look at 4 bridges, critical bridges in the country to identify where the vulnerabilities are and build the capacity in the engineers to be able to do the assessments locally, which is a very important piece. The engineers need to understand that this is their role.
Is there a case for engineers and I guess politicians too, recognising sometimes that we can't always engineer ourselves out of a crisis? how are engineers working with other forms of other disciplines to work out what we can build and what things we can protect, and what perhaps needs a more natural. I'm thinking perhaps of sort of planting mangroves instead of building seawalls. I know you can't do that all around the world, but
That's an excellent point. Engineers do not work independently. They recognize that there is a social infrastructure, and that's really the quality of life that we have worldwide. That's what this is all about. Civil infrastructure, physical infrastructure, the built infrastructure are all related to providing a foundation for social infrastructure, and then you've got the economic infrastructures that can pay for it all. It's all interrelated. Solving the problems in the river valleys, the riparian zones. Recent history in Calgary showed that where we tried to engineer the river to make it better, that's where the big damage was. Where natural riparian zone vegetation was in place, 3 or 4 days after the event, you couldn't tell that there had been a flood. There's a very important lesson to be learned there. But it's bringing everybody together to solve this problem. And just in closing, the climate is changing. Greenhouse gas, we talk about cutting emissions a decade from now. We're going to see more and more serious events annually going forward, and we need to adapt that infrastructure we got in place. Very important.